MAT 1122 Differential Equations 1 Lesson 2 Equations of the first order and first degree. In this lesson we are considering the equation of the form m plus n times dy by dx equals to 0, where the m and n are functions of both x and y. Find and so if you carefully look at this equation, you know that you can see that m plus n times dy by dx. If you multiply whole equations by dx, we can form this equation in that form, that is m times dy by dx plus n times dy equals 0. This is the most often using form of that equation, m times dx plus n times dy equals 0. Unfortunately, it is not possible to solve the general equation of this form in the terms of the finite number of functions, but we shall discuss the some special types in which can be done. In that lesson we are considering only the three basic types of that equation, how can be solved these types of equations, differential equations. So the types are exact equations, equations solved by separation of variables, and homogeneous equations. First we can consider the exact equations, right? So consider the equation. There is some equation is given. So first of all, I will explain how we can find whether the given differential equation is exact or not, right? So exact differential equations, right? What is our form? That is m times dx plus n times dy equals 0, right? Test for exactness is test for exactness. So you have to remember this thing, how we can find whether the given differential equation is exact or not. We can write daba m over daba y equals daba n over daba x. If these two are equals, that is the given equation is exact. I think you have a problem. What is this daba, right? Because this is come first time for you, right? If you write daba m over daba y, what is this? We can write this daba m over daba y. Meaning is these are the partial derivatives, right? Meaning is partial derivative of m with respect to y, right? So subject is y, we are taking the partial derivative of m with respect to y, so that's why we called daba n over daba y. And this one partial derivative of n with respect to x, so we can pronounce this daba n over daba x. If these two are equal, so we are calling that given equation is exact, right? So we will consider an example. Example 1, consider the equation y times dx plus x times dy equals 0, right? So we consider the example y times dx plus x times dy equals 0. This equation is in the form, in that form, so we can comparing with our general equation, that is m times dx plus n times dy equals 0. Here what is m? M equals here y times dx, here m times dx, it means m equals y, and n equals here x times dy, n times dy, n equals x. What is the test for exactness? This one. We have to find da by m over da by y. That's a partial derivative. You have to derivate these things, right? Then y is m equals y. Then if we differentiate y with respect to y, right? So answer is 1, right? Differentiate y with respect to y, because da by y, m is equals to y with respect to 1, that is 1. And we have to consider da by n over da by x, da by n over da by x. So differentiating x with respect to x, differentiating x with respect to x, that is also equals to 1. So then we can say both are 1, no? Then da by m equals da by y equals da by n over da by x. Da by m over da by y equals da by n over da by x. Our condition is satisfied, no? So it means the given equation is exact, right? I think now you can understand how we can check the exactness of the given differential equation. So first you have to check whether this given equation is in that form. If it is in that form, what you have to do, you have to identify m and n. So then what you have to do, then you have to find da by m over da by y. That means differentiating of the m with respect to y, and just then you have to find the da by n over da by x. It means partial derivative. It means differentiating of n with respect to x. Then you have to check whether it is equal or not. If these two are equal, it means the given equation is exact. If it is not equal, it means that the given equation is not an exact equation. I think you got the idea. And consider another equation. There is another one is given. So example 2. Right. Example 2. Right. We are taking tan x dx plus, sorry, we are taking tan y dx, tan y dx plus tan x dy equals 0. So this is also in the general form, no? Comparing with m times dx plus n times dy equals 0. Then we can see m equals tan y, no? M equals tan y and n equals tan x. So what we have to do is, if this m is in x, no? So first we have to, we are going to check whether these given equations are what exact equation or not. So I can check da by m over da by y, right? Differentiating of tan y with respect to y, you know that what is the answer? Sec squared y, right? Then we can find da by n over da by x, differentiating of tan x with respect to x, that is sec squared x. So then da by m over da by y not equals da by n over da by x. These are not equals. Therefore this equation is not exact, right? This equation is not exact. However, right, this equation is not exact, that is true, right? However, I am going to rearrange this equation. The original equation is this one. I am going to rearrange the equation by multiplying no, before multiplying I am we can do this thing, right? So you know that here give an equation tan y, no? So rearranging the equation, right? This is tan y, no? Tan y we can write sin y over cos y, no, times dx plus tan x we can write sin x over cos x times dy equals 0. Right, now I am going to multiply the equation by equation by cos x cos y, right, cos x cos y. Now we'll see what happened. Cos x cos y times sin y over cos y times dx plus cos x cos y times sin x over cos x times dy equals 0. So cos y and cos y cancel, cos x and cos x cancel, then it becomes cos x times sin y dx plus cos y times sin x dy equals 0. This equation is also in the form, this form, no, comparing with m dx plus n dy equals 0. M equals cos x sin y, no, m equals cos x sin y, n equals cos y sin x. Then we can find da by m over da by y. What is it? If we differentiate with respect to y, x is constant, so we can write cos x as it is, and if we differentiate sin y with respect to y, the if we differentiate sin y with respect to y, then you know that derivative of sin y is cos y, right? So we can find da by m over da by v equals cos x cos y, and next step is we have to find da by n over da by x. That is because we have to check our rule. So then if we are differentiated with respect to x, y is a constant, then cos y is, we can write as it is, and if we differentiate sin x with respect to x, then you know that derivative of sin x is cos x, so we can write cos y cos x. So then what you can do is, what you can see is cos x cos y and cos y cos x, this both are equal, therefore da by m over da by y equals da by n over da by x. Now the equation is exact, right? Now the equation is exact. Here here that you have to remember one thing, if sometimes the given equation is not exact, but you can convert this equation into the exact form, right? So by multiplying by something, so here we multiply by cos x cos y, cos x cos y. So this is called the integrating factor. Why is that? After multiplying, if we take an exact equation, we call that is integrating factor. There are some special methods to find the integrating factor. We will consider how we can find the integrating factor in next lesson, but you remember that. So you can by multiplying by integrating factor, you can convert some given equations to the exact equation. Now we did that one. So now we found only the exactness of equation. After finding whether the given equation is exact or not, then we can solve the differential equation, right? So we did these things. So sin x sin y equals this is the solution, right? I didn't explain how you can get the solution. I'll explain in next later, right? And before I explain how to find the solution, because that is end of that part. However, I am going to explain what is integrating factor. In this last example, cos x cos y is called an integrating factor because when the equation is multiplied by it get an exact equation which cannot be at once integrated. So we did that one, so we multiplied that one, then that is called integrating factor, then we got the equation is converted into the exact equation. Now we know that these are exact equation. Now I am going to explain how we can solve the exact equation and how we can write the answer. Okay, so I am taking again this equation. What is our equation? Now equation is converted into that form, no, this one. This is the equation, cos x sin y dx cos y sin y dy equals 0. Alright, so same equation I am taking now, converted one, cos x sin y dx plus cos y sin x dy equals 0. Right, so we consider one thing, right? What is this? This one, if we differentiate this one, cos x sin y dx, sorry, integrate, not differentiating, we are going to integrate this one. Then here sin, this is with respect to x dx, so it means sin y is constant, and we have to differentiate only cos x dx. If we integrate cos x, what is the answer? Integration of cos x, that is sin x plus sin x. Then you know that always in when we are doing A levels also you did same thing. If we are integrating, we are adding an equation, no, sorry, constant, because you know that the derivative of a constant is 0. So I am adding c1, where c1 is an arbitrary c1 is an arbitrary constant. Arbitrary constant. Right, I am doing same thing for the other part also. Cos y, this one, sin x dy. So now if we integrate with respect to dy, sin x is constant, right? Then sin y times dy, sin y times, sorry, not sin y, cos y, no, here cos y, sin x, cos y times dy. If sin x, if you integrate cos y with respect to dy, that's come sin y plus c2, where c2 is an arbitrary constant. Right, now we both the answers are same, but there are some constant, so c1 and c2. So in that equation, sorry, in this problem, that is not a really problem, because both are same and there are no constants. Sometimes here there are come another value, right? Here also a different value. In that case we need those constant. Then here with by comparing these two, you know that these are equal. So by comparing these two, you can write c1 equals c2, right? It means doesn't matter, so it is equal to 0 then, right? Then answer we can write in this form. How is that? Sin x sin y equals c. This is a way of writing answer. sin x sin y equals c, where c is an arbitrary constant, right? That is the way of finding general equation. So we can verify this whether our answer is correct or wrong. Verification. So here you take sin x sin y no equals c, right? Equals c. If we derivate this, right, if we derivate this, what happened? So this is the derivation of product. So sin x times, I'm taking other side. If you are going to sin y, if I am taking sin y in times, what is the derivation of sin x? That is cos x dx, plus earlier I take sin y times, then sin x times sin x times derivation of sin y cos y dy equals derivation of the constant is 0. It means same equation, no? Yes. This equation cos x sin y dx, cos x sin y dx, and cos y sin x dy, cos y sin x dy. Yes, our answer is correct. What is the answer? Sin x times sin y is equal 0, right? Okay, I will explain another example. I will take another example, then you can have idea, because I think sometimes you may have confusion with one example. So I am taking another example and explaining to you, right? Example 3. Right, x to the power 4 minus 2 xy to the power 2 plus y to the power 4 times dx minus 2x squared y minus 4x y to the power 3 plus sin y times dy equals 0. First we have to check whether the equation is in that given form. Yes, so we can compare comparing with what is our form, m times dx plus n times dy equals 0, right? Then m is equals this one, x to the power 4 minus 2xy squared plus y to the power 4. N equals this one, minus sign is there, no? Minus 2x squared y minus 4xy to the power 3 plus sin y. Here you can remove the minus sign, minus 2x to the power y, x to the x square plus y minus come plus 4xy to the power 3 minus sin y. Now what you have to do is we have to find da by m over da by y, right? Da by m over da by y, differentiate. If we consider x with respect to y, that is constant, then 0, minus x is constant, then 2x times there is a technical problem with my writer, so I will explain this again.